The learning outcome 1 gives us a definition of pressure. Pressure is defined as the force per unit area. Acting on the surface. Or in equation form, and remember you can use the equations as prompts in exams to help with those word definitions. P for pressure is F divided by A, force divided by area. The unit of pressure is called a Pascal, or capital P, small a for short. We'll see in examples in a wee second that the 1 Pascal is actually a very, very small pressure. So you'll often find kilopascals or powers of 10, 10 to the power 5. And the standard unit of area is metres squared, and as I'll show you an example in a wee second, the easiest way of dealing with that, if you've got dimensions in centimetres, is to do the conversion to metres before you work out the area. So for example, a car of mass 1200 kilograms has 4 tyres, each with a contact surface, i.e. how much of it's actually touching the ground, of 20 centimetres by 15 centimetres. Calculate the pressure it exerts on the ground. So we've actually got a wee bit of work to do before we can use P equals F over A formula, because we don't have a force and we don't have an area yet. So I'll spread out the working for this a wee bit. So first of all, for the force, well, the force that's relevant here for a car sitting on the ground, right, is equal to the weight. That's what's going to cause the downward force. So we can use the mass, 1200 times 9.8, and that gives us the weight. And similarly for area, we've got a wee bit of work to do. So notice there are 4 tyres, so it's 4 times, and the area is 20 centimetres by 15 centimetres. As I suggested, that's best done in metres. So that's 0.2 metres times 0.15 metres. And putting all that into the calculator gives a surface area of 0.12 square metres. And then our pressures are question mark. The pressure is force divided by area. Square metres incidentally are quite big units of area, so you'll see here we're getting fractions of that for our calculations. So do our force divided by our area, and that gives us 98,000 pascals. And as I was saying, we tend to get quite large values for these pressures. And learning outcome 3 is describe how the kinetic model accounts for the pressure of a gas. So the kinetic model is the idea we discussed at the start of heat. And it states, that the particles of a gas are in constant random motion. So that's our definition of the kinetic model. And this means that the particles will regularly collide with their surroundings. Notice it doesn't matter if they collide with each other. That's nothing to do with kinetic theory. But the key point is if they're colliding with the surroundings, then they will apply a force on those surroundings. And since pressure is force per unit area, then we have a pressure. So that's why all gases exert pressure.